Hello, this is Héctor, your AFM expert at Nanosurf. So today I'm going to show you how dirty is the glass on the camera on my phone. So for that, I have the industrial solutions, one of the industrial solutions AFMs, and I mounted my phone over there. You can see it. So I'm gonna step here. I'm gonna start the camera. I want to be on the front camera. So hello everyone. Let's start recording. Let's do that again. Hello everyone. This is Héctor, your AFM expert at Nanosurf. And now we're gonna move away from that. Gonna come here to the AFM control, which I'm also recording. So while I operate that, I'm gonna let you see what the AFM is doing. Yeah, maybe that. And now we move to go to the origin. Oh yes, sorry. Move to 0. So now I'm gonna tell the stage to go back to the origin position, which which I defined previously as a little bit above the camera. I use absolute coordinates, and I just tell it to go back to the 0, 0. Um, Need to be careful when using absolute coordinates, but I reference the system beforehand, so this is that we can close the doors of the chamber. This one, and then we can come here to the software which I'm recording. Now I tell the system to start approaching, and I close the acoustic chamber to prevent noises interfering with the scan. I choose dynamic mode, and the probe mounted here I think is a tab 190. And dynamic mode was a bad choice. You will see it in a moment. And the problem is the contamination on the surface. Because there is grease and water residues on the surface. Um, Dynamic mode has a hard time tracking the surface. I mean, I can track the surface with it, but it will take a very, very long time. It will be a slow scan. Because we don't want to be here forever. After trying a little bit with dynamic, I will switch to static mode. Which is cool here is that you can see it's trying to approach step by step, and you can see the Z axis having this sawtooth movement because it's approaching with the piezo and then moving the motor, and then approaching with the piezo again and moving the motor. You can see this as a little bit of tick on the laser. You see the laser is like flickering. It's because it's moving one step. Now we are close to the surface and we can start the scan. I choose for this small area. Always start with a small area if you don't know the surface. And yeah, start with a slow scanner speed because you don't know what you're going to encounter. If it is a surface you already know, then you can go faster or you can go large areas. But for the beginning, always small. So here you can see on the left image you have the topography. Below it is the trace and retrace, and in the tiny image on the right you have the amplitude. So it's not completely bad, We are tracking the surface, but the trace and retrace don't match, and it doesn't match because um, we're basically picking up contamination from the surface and moving it with the probe. And if we are not lucky, maybe even getting stuck to the probe. So here I'm considering if maybe changing to static mode. So change. So to change to static mode, I don't need to retract. I just disengage the feedback loop, change to static mode, and I need to lower the gain because for static mode that gain was really high. Now you can see that the tracking is a little bit better. I'm zooming out to see if it is a problem with this area or is a problem with the tracking in general. It's cool here also that on the camera you can really see the laser moving position. I want to maximize that display a little bit because usually in the deflection or your error signal, if you want to call it like that, um, it's easier to see if there is noise in the scan. But I'm more or less happy with the parameters here. Maybe I'm scanning too fast, but it should be okay. Yeah, I'm just testing how much gain I can use before the system starts to be noisy. So this is more or less maximum I can use for these parameters. And now I'll restart the scan and complete this as a new scan. Mm, some people might ask why of the two views of the two camera views, one of them is green. Well, this is because it's optimized for a certain type of samples, which I cannot tell you right now. But this color really helps visualizing the things that needs to be visualized. As you can see, the surface of the phone, of the glass cover of the camera, it's completely full of scratches. Um, but although they look a lot, this is we're talking 2 or 3 nanometers maximum. It's nothing. It's almost flat. And these scratches are so tiny, and they are they're so separated, and they are not regular that they barely affect light in the visible range. One important thing to notice is that um, so in dynamic mode we see all the contamination and it's hard to track the surface. Not impossible, but hard. In contact mode we don't see the contamination because we are cleaning it with the tip. Basically, if there is water, we are piercing through the water layer. If there is grease, we are brooming it with the tip as we scan. So yes, we track better, but no, we don't see the contamination with this mode. If we use a softer probe and less force, in principle, we should be able to see the contamination. But here I'm using a rather large force and the probe is rather stiff. it just occurs to me that maybe um, if using diamond tips and a script, it might be possible to scratch the surface of this glass and create a like Fresnel lens or some sort of interference grid, maybe to create an interference pattern or to maybe separate the different colors in the light. That could be an interesting effect. Um, it just occurs to me that probably with this flat surface and this scanner range, maybe it's more accurate to use a parabolic fit instead of a linear fit, because we can see some that the image is more bright on the center and is dark on the edges. But this is a normal thing with this type of scanners. Yeah. So the surface of my mobile phone is full of scratches. It really doesn't matter. At least so far, I think it's not affecting the image quality. At some point, these scratches will diffuse the light, and it will look like this, like the images are blurry or they are not so clear. But so far, it's okay. I hope you like seeing the difference between dynamic mode and contact mode. In dynamic mode, if you remember, we were able to see the contamination, but of course you need to optimize for that. And in general, it might mean higher gains and lower scan speed. In contact mode, we can scan faster and we get to see the surface, but you need to remember that you are brooming away the contamination. So in a way, you are modifying the surface. You're cleaning it, but this is a modification, of course. I also hope you got the feeling that these industrial AFMs are easy to use, because they are really easy to use. It just changed the size, but it is still the same system. Um, and I hope to see you next week.